Hello everyone, I'm back. And I have another update, and this time it's kind of another rewrite, yes. But good news is this runs on the browser now. Yay! So I ported it over to WebGPU and WASM. It's still written in Odin, it's just that I'm targeting WASM and the browser. Now I had to change lots of things in how it works internally, like the data structures I use, how I do lighting. I had to do a bunch of optimizations. But after a few weeks, I'm back where I started in a way. You know, I have something that works. I have the procedural generation I had before in the other video, so it's now here. Let's help it. Oh, fine. So yes, procedural generation is still working. I can edit the world as well. You know, I can delete stuff. I can put emissive things. I can delete stuff. These balls are hollow, so yeah. So everything we had before is still working, but on the web. The playground I had on the previous video is, whoops, it's working here now. You will notice that if you compare this to the previous video, you notice that the inside converges way quicker. So I did some optimizations to improve convergence speed. So now it's that's much faster. You can still see a little bit, especially on places that are not lit much. But it converges very quickly now. But also, yeah, a few things. So one thing that was missing, and I really needed to implement it this time, is some better debugging capabilities. So the thing everyone has that I didn't have, so I wasn't cool enough, is the debug view where I can see how many steps I'm doing on my DDA and traversing my data structures. So now I have it. Cool. So. And you can see how much more expensive going through those thin spaces is, which makes total sense. So yeah, I'm cool now. I have things that look pretty and help me debug. Okay, honestly, it didn't help me that much because I was mainly just looking at the FPS. But it's nice to like visually represent this and corroborate that, hey, what I think that happens is actually happening. The other thing I did was I had to make the reservoir, the probes. I stopped calling them probes, by the way, because it's, well, I don't know if calling them probes is the right naming, whatever. But the probes or reservoirs or whatever, they are bigger now, and you can watch them if I remove the light smoothing from the indirect. Oh, actually, no, there's a better way, which is debugging and using the indirect light. So with this debug mode, it's something I had before, like right when I started, I had this, and then I didn't have it again. So with this, I can debug what the indirect light cache looks. And well, maybe it's not that noticeable, but the reservoirs are way bigger. It's bigger than this. Whatever. And then yeah, some direct light debugging as well, because I had tons of issues like updating the direct light because it's used a different data structure. And here's the interesting part. So the direct light, when editing, I can choose or I can switch between updating using the CPU. So I'm using WASM multi-threading. So when I move the sun, let's say I move the tilt of the sun, this actually updates in CPU. Now I could make it update in GPU as well, and so what I do for that is what I had before on Metal, which is this low res prepass. So let's turn this off, refresh, and you can see that there's low res prepass because when I'm sampling, not all the pixels, not all the boxes are sampling are actually detecting if they are hit by the sun or not. This is because it's starting out as lower resolution. If I have a 1:1 resolution, then it shows correctly. If I want to run it a little bit faster, I can do this, and I can also skip empty spaces using the depth buffer I generate from the low res prepass. That can cause some flickering when you are looking at things from. Oh, actually, let me render. So when you're looking at things from farther away, it causes a little bit more flickering because there are some pixels on the edges that may get the wrong depth. But more or less, it works very well, and it is a performance improvement in the sense that basically the high-res prepass starts the race whenever the low-res prepass stopped, right? And the low-res prepass runs over way lower amounts of pixels, so that's actually helps a little bit on the performance side of things, and at keeping things dynamic, because this is updating the depth, the direct light data all the time. But if I'm not moving the sun too frequently, I can avoid this completely. Just use the CPU driven light, direct light, and that's it. And then I can free more GPU for all the meaty stuff. Now, since I made several performance improvements, it now means, and I'm using less memory, it now means that I can have way bigger worlds. And if the WASM worker hasn't died yet, which can happen sometimes, it just decides to die. It unalives itself. Okay, yes, it unalived itself. Sorry, let me go and do crater. This is a big scene, so it makes sense that it takes a little bit longer. I don't have any sort of streaming yet, so I'm just generating everything on one go. Now, this is a big scene where the voxels don't look like voxels anymore. Now, there's something that bothers me a lot here, and maybe it bothers you as well, if YouTube doesn't mess up the compression, which is all the flickering and aliasing that you can see there, like in the middle of screen. Can you see all the flickering on the mountain? And so this happens because we have this high frequency of lines going dark, white, right? And this is due to how each voxel calculates how much it's lit. It's illuminated. Now, there are several ways of solving this. I could generate a surface normal approximation and then use that to decide, which how much the sun is illuminating that piece. the way I'm doing it is I do a convolution, a spatial convolution. So this is just this. So let me use no convolution at all first. So no convolution at all. It's almost a pair voxel light, which is a different style from the one I want to go to. Like, it looks nice at a distance, but if you look closer, all the details, well, not all, but lots of details are lost, and you'll still have a lot of flickering. This 3x3 plane is a very cheap convolution to try to somehow approximate what the slope of the surface is. And so it kind of, yeah, it tries to calculate the normal, but it's in a very cheap way. It gives a very nice, interesting result, but it looks nice when I'm still. But if I move the camera, I can start seeing all that flickering or all that aliasing. And so the way of removing that aliasing is do a convolution on the spatial domain that smooths the whole color. And it gives me this. And now when I move far away from the mountain, I don't see flickering anymore. Now sometimes having those lines is actually nice, the lines we had before, because it's like a what's the name in English? Like a level lines. Like when you do graph analysis and you cut the, well, whatever. I know what the in English is. Líneas de nivel, whatever. So it looks like that, so it can give you an idea of how the surface is. So I don't know, maybe it's something that in some situations could be useful. But if you want a smooth surface, then that 3x3x3 convolution gives the nicest result. It's a little bit heavier though. So what I was planning to do is not doing it always, but only do it when I visually need to reduce the aliasing. What else? So I added some toe mappers. Honestly, this is mostly like copy pasting some toe mappers from the internet. So yes, I don't know, choose whatever toe mapper you prefer. By default, I'm using AGX because it's, I don't know, I like it, but you can use ACS if you want. By default, one thing I did, like I explained, is reduce the occurrence of aliasing. But when aliasing actually occurs, especially on borders and on distance, I can still use a screen space aliasing, anti-aliasing, sorry. And so right now I'm using CMAA2. Again, it's just I look at the paper and the GitHub example, and I try to copy paste whatever they had, and it kind of worked. I don't understand everything that's happened in there, but yeah, it's, if this option is turned on, you only see the differences around here. And when I move, you can see some aliasing. It's not that bad. And if you have a super beefy computer, then what the best thing you can do is like super sampling. Just render at 4x the resolution, and there you go. No more aliasing. Because this is like more than 4K, so whatever. Now this is very slow here, so let me put it back to 1. Thanks. So editor-wise, I'm still working on this, but yes, there are some logs here. This log is very useful because it's what I'm used to copy paste and put here to set up the camera. You may have noticed that I changed all the syntax for my language. Oh, wow. I'm not going to talk about that right now. That's too long of a video and I'm tired. So another day I will do something that's specifically for procedural generation. I made some changes that hopefully you will consider improvements over what I had before. I do, at least. Again, editor-wise, there's a materials panel where you can configure your materials, if it's emissive, not emissive, opaque. I only have 3 right now, and glass is not working yet on this web version, so I'm not going to show it. The nice thing is that you can put a label to the material, so then you can go to the editor and use it with the label, right? So this label, for instance. And you can import local box files. This doesn't leave your computer. You can use this offline. This is just for like referencing a file and using it on the editor. And yeah, I hope you liked it. Let me play around with some emissive materials here. Let's go put some lights. Yay. In terms of FPS, honestly, I don't think this is barely touching 30 FPS, and I even removed the FPS counter because it was lying me on macOS. Because, well, a different issue, and there was a driver issue, and so it was telling me, oh yeah, it runs at 120. And technically, yes, but there was a lot of stuttering due to some completely unrelated thing, and so I don't know. I need to add it again and make sure that it reports properly. I didn't want to make a video and with the end of the video saying, oh, 120 FPS, and you clearly see that it's not 120, so it's this guy is lying. But on smaller scenes, it does go very quick, like very fast. So yeah. Okay, I'll just stop talking. It's just, it's fun. I can walk around the world, see in how many ways this is. Oh man, why? I was so why are you breaking my world? Why? What is this? Come on. What? Oh, I know. Okay, yes, I know what's yeah, yes, of course, I know what's happening. Whatever. Don't. Hopefully, people just left the video when I was talking at the middle of the video or even before, so people don't look at the end. So that's fine. Okay. Bye. I will see you in the next one. And hopefully I will improve enough of this so that I can actually share it online with people. Honestly, I had a few very bad issues, especially on Windows. So I was testing some big procedural generation Windows, and the whole canvas started flickering like crazy to the point where I got a headache trying to, like, literally got a headache due to the flickering and trying to debug this. And when I closed the browser and everything, like the screen just kept flickering on that specific square, and everything was closed. And I don't know, it was like very broken. I don't know. I don't want that to go out on the wild and break people's graphics card or whatever. I don't even understand. Like, yes, I have an idea of why that may have happened, but it's still stupid that the driver allows that to happen, I guess. Well, whatever. Bye.